Hello everyone. Today our topic about the security problem is enabling the efficient search over encrypted data. Um, Firstly, let me introduce you our team member. We have Ali Reza. He's a PhD student in our department, and myself, Kang. I'm a master student in our department, and we also have Lee. He's a PhD student from chemistry department, and he is also a master student in our department. As we mentioned of the title, we want to enable the efficient search on encrypted data. And what kind of encrypted data? Here we want to focus on the data in the cloud. We all know that because of the rapid expansion of the data nowadays, the data owners they tend to store their data into the cloud to release the burden of the data storage and maintenance, and also they can cut down much cost because they do not need to maintain the data or hire the professionals to take care of the data. So, along with the popularity of the outsourced data, the cloud server, we have the new challenge of the security in cloud servers. The cloud customers and the cloud servers, they are not in the same trusted domain. So that means the customers, they cannot forcing or really take control of the data, which means the data can be under the exposure to some risks like unauthorized access of the data, or even the data center, the server, sometimes may not be trusted. We call it like a curious server. It tries to know what's the data is storage. So the most indirect way to protect our data, of course, is to just encrypt our data. But a new problem is that if we encrypt our data, we must have the new way to search the encrypted data. So that's also one of the most important computation is searching the demanded data in our cloud. So, but to solve the problem in our research, we want the server to search on the encrypted data. We know that the encrypted data is different from the plain text. The plain text they have kept all the features of the content, so we can just use the plain text keyword and got what we want. But for the encrypted data, it loses all the features it has before. So we must encrypt our keywords in the same way to get the result. But it can be very challenging to do that, both in the efficiency and also in other ways, like to enable multi-keywords and to enable the fuzzy keywords. So here we have seen that many papers to do the ranked search, multi-keyword search, or fuzzy word search, but they didn't combine these techniques together. What we want to do is that we want to combine these techniques to provide our user a better user experience. Our users, they prefer the experience when they use Google, so we try to provide the experience as closer as the experience they use other search engines. So our approach to the challenge, as I already mentioned, is to combine some techniques. The two most important one is the multi-keywords and the fuzzy keywords search. Here is an example. A multi-keyword can be like 2012 World Cup Germany. We know that Germany, they got the champion for the World Cup in 2012, and or such as dead money. Multi-keywords means we have more than one word. If we have only single word search, we need to try to use a single word, different single words various times. Like you want to type in world or World Cup or Germany, and you may get many irrelevant files or articles. But if we have the multi-keywords, it can increase our efficiency sharply. And a fuzzy set of these keywords can be like this set 2000 a star 2. That means maybe our user, they forgot the exact year, and they maybe have some typo in their keywords, or maybe they have the typo of the word to word. But anyway, if we have the fuzzy sets of all the keywords and we use all the fuzzy keywords to search the result, we can provide our users with the correct results, even they have a typo in their search. And for the data mining, it can be data mining or dash mining, because in our file it can be in two variants, or for our users they can type in different versions of expression of the keywords. So the fuzzy keywords can be very useful. And this is a picture shows the process of multi-keywords, and it's also suitable for the fuzzy keyword search. Firstly, our data owner, here we use DO to represent, will get the access to the encrypted documents and send the keyword based query to the data center, and the data center will give him the right to do the search, and then the data center will deliver the search request, and the cloud will return the results to data center and our owner. And a ranked multi-keyword search means that we not only support multi-keywords, we also support the ranked results. That means the results we get is ranked according to some features in our data. We can consider like frequency and positioning. If a keyword it appears more frequently than other words in this document, then this document or this result will be ranked top in the results than others. Also, for the positioning, if a keyword appears in a title of an article, or more in the front of a file, we also consider it's more related. About the fuzzy keyword search, we have already seen the example. Here are two techniques we usually use. The first one we call a wildcard based technique. Like we have a keyword castle, and every time we can insert or use a letter to replace a letter in castle, like star castle or star as, and so on, or C star as. So that means if our user they have some typo or they have the wrong word, something, we can still return the correct result. Here the star can be one letter, can be empty letter, or can be various letters. Another technique is gram-based technique. It deletes a letter each time to get a whole combination. According to our work, I think our contribution can be summed to one sentence. Thus, we combine the two important techniques to fuzzy finding the multi-keywords into the datasets, and then we can fuzzify each word in the multi-keywords to get the results we want to support both the fuzzy keyword search and multi-keyword search. Besides that, we also build up a ranking index based on frequency and positioning, and also we have considered a better method for a scoring function. As to the scoring function, it's about give a score to each document. It's an improvement version of our rank system. We found that most of the parser works they use some very simple parameters, only one or two parameters. Here we try to improve them by to add some new parameters like the position of the keyword and also like the freshness of the document. I mean, how much times the document is used or being searched, or when did the document added. If the document is a new document and it has more chance to be ranked top. Some other consideration involves to increasing the security. That means use a non-deterministic scheme, and also to enforce the randomness. And we also analyzed some useful hash functions to find which one will be more suitable for our scheme. Also, to improve the efficiency and accuracy, we made some changes to the past scheme's indexing, also in how to make the proper brackets. To sum up, searching on the encrypted data has a good progress, but they still cannot compare to the engines work on the plain text, especially about the speed. In our method, we need to pre-fuzzify so many keywords into a huge set that can cost pretty much time to get a good result, and that's what we need to work on to improve in the future. Here, because of the time limitation, we only list our work and didn't go deep in details. We really hope this presentation helped you to know more about cloud security and its usability. Thanks for listening.